So this worksheet, 2324 worksheet, has just some basic differentiation, but many of these problems require a rewrite first. So what I would like to do is kind of just go through and talk about some of the nice rewrites that you would want to make before you actually jump in to differentiate them. So 1, 2, 3, 4, ready to go, perfect. But number 5, you have to take that third power and put it onto both things. So that's 16 to the third, x to the third. We don't know how to differentiate that any other way. A way is coming, but at this exact moment, we don't have a way to do that, okay? For 7, you want to write that 1 over x squared as an x to the negative 2 power. Same thing for 6 and 8. That's s to the 5th over 2 to the 5th. 6 is s to the 5th over 32, 2 to the 5th. You need to write this as the square root of 5 x to the 1/2, because if they are stuck together like that, we can't differentiate it yet. We do have a formula coming that will take care of that. So 10 and 11, what do we have to do to 10, 11, and 12 as well before we actually can differentiate those? What do you have to do before? We have to do the distribution. Now, a formula is coming that we can avoid that if it's a really disgusting distribution. But for now, we either have to do the distribution, or if you think about there being a multiplication in between them, what rule can we use? You could use the product rule. So you either have to distribute or use the product rule. It's one or the other. You decide what you want, okay? I want to talk about 13. For 13, I would think about this as a 1/3 power. And you would either have to use the product rule, which is okay, because that is technically a multiplication. But to me, the most efficient way is to distribute that in. And if we distribute that in, that will make it so we can just follow the individual power rules. So to me, I think that's probably the best way to rewrite 13. Again, if you stop here, you have to use the product rule. If you distribute when possible, you get to avoid the product rule, okay? So that's something to think about there. 14, what rule do we have to use? You have to use the quotient rule, bottom times the derivative of the top minus top times the derivative of the bottom over the bottom squared. Same thing here. Now, here you don't have to use the quotient rule if you think about that as x squared divided by the square root, 4x divided by the square root, and 3 divided by the square root. Now you notice I wrote the square root. We always want to rewrite the square root as a 1/2 power. We're still not done. We still would have to do individual quotients, which why would you want to torture yourself? 2 is 4/2 minus 1/2 is 3/2. 1 minus a 1/2 is a 1/2. And then here, that 1/2 we can pop up and make that x to the negative 1/2. Now, I've not done any of the differentiation rules. I've just done a rewrite to get ready for the differentiation rule, okay? So 15, we're stuck doing a quotient rule. 16, we didn't have to make it like this, and then we can do the power rule. So 17, how would we write that so that we could get ready to differentiate? X to the 4th minus x to the 1/4, exactly. I want to do 18 with you, okay? The derivative of that, the power drops down in front, The power goes down by 1. That's almost a clear example, almost as if there was an n sitting there. The power dropped down in front. The power goes down by 1. It is what it is. Just leave it. Okay. 20, we have to use the quotient rule. Please make sure to put things in parentheses before you do that. 21, what's our rewrite so that we can do the derivative? What's our rewrite? How could we rewrite this piece right here? That would be x to what power? 2/5. Remember, the index is your denominator. The power is your numerator. So that's why it's 2/5. And now we can do the rules. Drop the power down in front, bring the power down by 1. Remember, a power on an x is the first. What is the derivative of x always going to be? 1. So what's the derivative of 2x? 2. 7x, 7. Square root of 2 times x, square root of 2. So don't mess up those x's. So 22, do a rewrite. I want to talk about the rewrite that's happening for 23. So this is x to the first times x to the 1/2. You could technically do a product rule. First times derivative of the second plus second times derivative of the first. You can do that. But why? Why not combine those, make that a total of an x to the 3/2? Now, this technically is a total of an x to the 5/2 because 2 times 2 is 4. 4/2 plus 1/2 is 5/2. But because of the fact it's in a denominator, flip it and make it a negative, and that's what you want to differentiate. So the main focus of this worksheet is how could I rewrite the problem to make my life easier so that I can use all those rules? Because there's going to be some stuff coming in the next section where we don't have the option of rewriting anything. And so we do have to use some funkier rules than what we've even learned so far. So so that's a little that there. V24, that's a nice problem. It's actually just 6 t to the negative 5/3. Now let's discuss why we got that. It was in the denominator, so to flip it, we have to make its power negative. The top is our numerator, the bottom is our denominator. So hopefully that, now I haven't done the actual problem yet, have I? Have I differentiated? No. So the rewrite doesn't count. You're just starting, getting it better. Oh, now I still have to take the derivative. 25, you're stuck, use parentheses, use the quotient rule. 26, distribute in when all possible. So I would rewrite all of my square roots as 1/2 powers and then distribute in, then do your derivative. Okay. So I would, if you're writing on your iPad to keep track of things for yourself, I would maybe make the rewrites in one color and then the derivative, make sure you have the symbol on the derivative and then make that maybe a different color so then you can see, okay, I haven't done that derivative yet because I can't tell you how many times a student on one of our quizzes or tests to come will do a rewrite and think they're done. Do a rewrite and then I still have to take that derivative. So the bottom page is mostly about our trig functions, okay? So the first two are great, okay? The second two, what rule do we have to use? You have to use the quotient rule. So please, that one put in parentheses, okay? 5, put this in parentheses. 6, it is really not helpful for number 6, unfortunately, to not use the product rule. It comes up one way or the other. So I would just use the product rule the way that sits right off the bat. So put a little dot there and think about first, second as your two pieces. 7, I would put a little dot between them because you have to use the product rule, okay? Now, what I would like to do is I would like to do number 8. Go ahead and skip number 9. And actually, we'll do 10 together, but you can skip the rest of those, okay? So let's talk about number 8 for just a moment. Let's do that one. It says, find an equation of the tangent line to the curve at the specified point. So we have the curve y equals 2 sine of x. Remember, that's just our sine wave that has a double amplitude. We are looking at the point pi over 6, 1. Okay. That is not the point. If you plug in pi over 6, you do not get 1/2 times 2, which is 1. I think they wanted to make that pi over 4, pi over, okay, wait, pi over 6 is 30, right? The sine of, oh, it is, never mind, okay. I was just like, wait, is that right? Anyway, brain fart there. Anyway, so what do we have to do for a tangent line? So the first thing you always find is y prime. Second thing you always find is the slope by plugging in your point. And the third thing you use is y minus y1 equals m times x minus x1. So no matter what, before, remember, we had we had that long formula for step 1. Now we have our shortcuts for step 1, which is great. So our first step, the derivative of 2 sine of x is 2 cosine of x. And so in the second step, to find the slope of the tangent, I'm just going to put our x value of pi over 6 into there. Well, the cosine at 30 degrees, or pi over 6, is square root of 3 over 2. So if I plug that in, 2 times square root of 3 over 2 is just square root of 3. So now I have my slope. And so now I use my slope of square root of 3, and I'm going to use the point pi over 6, 1, and we got the equation of our tangent line. So it's going to be y minus 1 equals our slope times x minus pi over 6. Now, because we have that square root of 3 and pi over 6 and distributing it and all that stuff is not helpful, just leave it. Just leave it. That's your answer. Okay. So there you go. Continue to work on those. There you go.